Alright, so this time we have a bit of a different thing, and it's definitely not my most prettiest work, because I did a lot of copy pasting instead of making some functions for it, because Python was not being friendly with me. So this time we have a bunch of clusters here, as you can see here in figure 1. So what's happening is it's gonna be k-means, and then based on the clusters, the center of the means will be moving around. So let's just drag this down here, so you can see this is then figure 2. So now we have a little center here, and then on the next figure, there we go. You can see that now we have some blue here. All of these green ones down here became red. And as I said, this is just based on these 5 spots right here in the center. And then we move the center points out. So now I color them black to make it more visible where they are at. And then we recolor everything with that is closest to this one. The blue one doesn't really change much. This one just this goes from green to blue. And as you can see, all the red ones down here have become green instead. The center 2 here has become red, and a bunch of these purple ones have become blue. Then we move the center points again. So this one moved a little out. This one barely moved. Like this cluster out here is pretty much like for itself, so it should be fairly easy for the blue one to find the center spot. Then down here, the green moved a fair bit out to the right. Red one moved a fair bit up to the left. Purple one moved a little bit. And then we recolor again. So now this little section here became green. The blue one hasn't changed at all. A little bit more red here. This singular one became blue. That's the change for those. Then we move the center points again. And as you can see, the blue one just stays. Like this cluster is basically already done. And then we have the green one. Then we recolor. So yeah, just a little more red. That one became purple again. Moving the center points. And recoloring the things again. So, as far as I could tell, the only difference between these two images is that little one right there became red instead of green. That's the only change I could see. So at this point I chose, okay, let's just stop, because I had to do a lot of copy pasting for the things to work here. And then the last little bit of moving the center points. As you can see, it's barely changing where they are at. And then we have here, due to the assignment, I had to spawn 100 new points. So all these beautiful black points here are just new spawned in points. The center points are still in here, they are still black. And then we color all the new points based on the center points of the various colors. Okay, let's just get all these clips down real quick. Alright. So, the code, as you can probably already see here on the right side, is a lot of copy paste. So we imported a fair few functions here. Matplotlib to make the functions I showed. NumPy to help me a bit on the way with getting the means of the lists and the minimum index. We'll get to that. Again, random seed. It's just nice to have seed, because then yes, it's random, but I can get the same result each time until I actually remove the seed. So I don't have to just look at different results every single time. Math distance times leap, I didn't actually get around to using that because I had issues with making Matplotlib work the way I wanted it to. But yeah, then we have a class point, we have x, y color for set point, we have a function to create points, and as you can see, this is just randomness. The x and y will come to later. Then we have sort by color. That is one of the ways that I make sure where I need to put the new centers when I do means. Z-axis is just right here, is to make all the figures have the same limits on their bars. Mean, of course, we'll get to that one, what x and y is. This is how I change up the center points of the k-means. So yep, then we have the subplot, z-axis, nothing special here, just making the figures. C20, then we have a little color list here, and number of clusters, number of points, and a k. To be fair, I don't think I actually use k because number of clusters is basically the k. Empty cluster array, make the clusters and create points as you saw up there. Randomness so this is how I make the clusters. I choose a random coordinate point somewhere in the figure, and then the points within that cluster has a variance of 15. So that's how I made the 5 clusters. A random coordinate set is chosen that can be based anywhere in the figure, taking the 15 variance into account, and then it's just making the random points all over the place. Each cluster has 30 points, as you can see. And then we scatter them out, so we have the just bases here, so figure 1, AX. I just went with the alphabet. Yeah, I could have just about gone with numbers. Okay, and then we have my center points here, so I just made them there in the center without really doing much to them. And then plotting them out. Okay, so now for a little bit more fancy. So distance equals 0 is 5, so I'm making a number array of 5. And then I'm going through each cluster and each point in each cluster and saying, okay, so the distance of the blue center to the point goes into 0. The distance between the green center point and the point, and the red and the point, and the cyan point, magenta point. And then at the end, I use argmin here to find which of these 5 indexes has the lowest distance. And then I use this index number to color my points. Then we have combined cluster. I'll get into that in a moment. And then 4 cluster in clusters, 4 point in cluster. And then here we have the color list I had earlier to now recolor my points in the figure based on what the minimum distance is to, or rather which center point is the closest. Alright, so now of course I had to change where the center points are now. So what I did is I made this combined cluster here, and every point is put into the combined cluster, and then I sort them by their color. That's why I needed them to be numbers all of a sudden instead of just the character for the color. So if we go up here, sort by color, pointer color. That's all it does. It just returns the number that is the color of the point. And that's how I sorted this combined cluster list, which holds every single point. As you can see up here, it just appends the point every single time. And then I made 5 new lists here. And then for iron range 0, no points. And now here's where the combined list comes in, because it has been sorted based on color. So I know that the first 30 numbers here will be blue. And that's why plus number of points here, because the next set is green, times 2, the next set is red, times 3, times 4, cyan and magenta. So that's how I changed it up, so it would be a little bit easier for that. Now again, a lot of this could have been done through functions, as you will see. Most of this code is just going to be copy-paste, because it's the same function going over and over and over again. But because I'm not too friendly with Python yet, I just ended up doing copy-paste work. So yeah, after this appendix up here, I do blue x, blue y equals mean of chords, blue cluster. And then we have here, define mean of chords, the point list. X is the mean of the x coordinates, and y is the mean of the y coordinates. So yeah, that's how I'm changing the center points. So you see here, blue x, blue y is the mean of chords of the blue cluster. Green for green, red for red, cyan for cyan, and magenta for magenta. And then I go through every single point to make it visible on the next figure, and then I am putting in the center points as black this time, because as you saw, it would have been hard to notice which point is the center point if they didn't stand out. So now I just make them black instead of the color that they were governing over, since you can just see that from where they are at in the figure. Okay, and then we are doing it again. Distance, combined cluster. Next figure shows it. Sort the combined cluster. Make these clusters empty again. And as you can see, this is all just copy-paste work. It is the same lines over and over again. And I really should have made a function for it. But for now, me and Python are not the best of friends. So I will at some point probably revisit this and make it prettier. Now, as I mentioned in the start, at some point I am creating 100 new points. They come in here. New points list for I in range 0 to 100. Create some points. And as you can see here, they are of a variance of 48 plus 1. So they'll be somewhere between 1 and 49. And as you could also see in the figure, they were all over the place. And then 4 clusters in cluster for point in cluster, just so I can have the original points on the figure. And now, here's a thing I'm not too much of a fan of from Python. As mentioned earlier, I'm kind of going between numbers and letters for pointer color. So up here, I'm scattering based on the list, because right here, the original numbers, the original points, have a number for the color. While the new ones I just made, because I want them to be black, they have a letter instead. And that's the letter is what it's expecting here. So yeah, I'm not used to Python, and this is odd to me that you're just allowed to change a part of a class object to just be now it's a letter, now it's a number. But it worked out in the end, and I'm just gonna leave it at that. So yeah, NX scattered the original points, NX scattered the new points, and then scatter the 5 center points. And then again, we are doing the distance for it to color the new points. And now, since I'm using this function from up there, now we have numbers instead of a letter. So OX scatter the old points, OX scatter the new points, and scatter the center points. And as you can see, now I made it to look fairly nice when I start the video, but when I play it, it becomes like this. So this is just to show that I didn't cheat. If you can just see these figures real quick, like these are my many figures, because I just could not get it to work in a better way. And yeah.